So question 5 asks to solve each equation below for the given variable. And I have to tell you, solving an equation. Let me tell you what it is not. It is not looking at the equation, guessing a value of x, and then verifying that that makes the left and right hand side the same. It's a it's a good thing that you can realize that in order for it to be a solution, it has to make both the left and the right hand side of the equal symbol certainly true. So if I know what x is, when I plug x into this side, I don't care what x is, but it has to make that side 11 so that it truly is 11. That's guessing x and then verifying that x corrects. That's not solving an equation. When I ask you to solve an equation, I'm looking for you to show knowledge of the steps and processes of solving an equation. So, for example, one of the things that you can do is eliminate parentheses when you look at the left-hand side here. So I may take this problem and rewrite it as 2x plus 1 and then write plus 4x and then minus 8. Now and then that still equals 11 on the other side. Now, when I'm looking at your work, right, if for example you wrote a plus 8 there, you failed to realize that it's 4 times negative 2, so it's a negative 8. Or perhaps you didn't even write that. Maybe you just wrote 4x minus 2. You failed to distribute this 4 across this argument inside the parentheses, the x minus 2. When I don't see that, I at least understand what you're not doing. And if this is, I think this is a 4-point question. Each part was 3 points. I could easily give you 1 or 2 of the 3 points if mostly you're doing things correctly. But I can't do that if all I see is that you've guessed an answer for x, and then you're just showing me that you're verifying that it really is that. So 2x plus 1 equals 4, and then minus 8x. I'm going to combine like terms on the left-hand side. You can see I have 2 x's, and I'm adding 4 additional x's, and that's a total of 6 of them when I add them up. And then I have a positive 1 and a negative 8. That's negative 7. I saw several students write that as positive 7. It's a negative 7, and then that equals 11. Certainly, if these are really equal, I can add the same to both sides, and it doesn't change things. So I'm going to add a 7 to both sides. I end up getting just 6x on the left-hand side when I add 7 to that side. And on the right-hand side, when I add 7, I get the number 18. And then if I divide both sides by 6, you can see that 6 times x divided by 6 is just x, and 18 divided by 6 is the number 3. So x is 3. And of course, I verified that. I think I just grabbed my calculator and plugged 3 into this expression here and here. And I was carefully using these parentheses, but I ended up seeing that, yeah, it did indeed make it 11. And it was 11 on the other side. So that's the verified solution. Let's look at B. Same thing. I'm going to use the distributive property on both the left and the right hand side, so I get to see this happen twice. That's 4x and then minus 3x minus 6. Notice the minus 6 plus 11. Over on the other side, I have 6 times x and then minus 30. On the left-hand side, when I combine the 4x and the negative 3x, I just get an x. And when I combine the negative 6 and 11, I end up getting a positive 5. So I've got x plus 5 on the one side and then 6x minus 30 on the other. I guess I'm just going to take away an x from each side, so this becomes 5 equals 5x's minus 30. Again, you can see as I move from here to the next step, I'm subtracting a single x from both the left and the right. Now I'm going to add 30 to each side, so I end up getting 35. That's 5 plus 30 equals 5x. That's what you get when you take 5x minus 30 and add 30. And then finally I'm dividing by 5, and that gives me that 7 over here and x. So x is the number 7. X is 7. So let's move to part C. I think part C, this is probably a little soon for this. We're going to definitely get better at this. This may be a problem that you don't have mastered yet, but I prefer always to clean up fractions if I'm looking at something like this. And I know that I can clean the fractions up on both the left and the right hand side. If I multiply both sides, in this case, I'm just going to multiply both sides by 12, which is 4 times 3. And I'm going to put it over 1. So here I'm going to multiply 4 times 3 over 1. Now, the reason why I'm doing that is if you look at it on the left hand side, I have this giant 1 that I'm forming with this 4 and this factor of 4. This part right here is going to be locked up in parentheses. So it is a 4 times a 3 times blah, whatever the parentheses in. So that's a giant 1, and this becomes 3 times the quantity of 2x plus 1. And I think I normally show this in 2 steps, and I'm just jumping to 1 step here. But on the other side, you can see I have this 3 and a 3. And notice it is a 4 times a 3 and then times this 2x. So it's all multiplication. There's this giant 1 of 3 over 3. And I'm left with a 2x and then times the number 4. So if I simplify the left, we have 6 times x plus 3. And on the right side, we have 8x. I can subtract 6 x's from each side. When I do that, I get 3 equals 2x. And then finally, if I divide by 2, I get that 3 halves is what x is. So I'm just going to write for here, x is the number 3 halves. And then you can, plug that in. Get good at quickly grabbing this value and plugging it in here and here, and using your calculator, just verifying that you get the same thing on both sides. I believe when I put that number in, I get that the left and right both become the number 1. So 3 halves does indeed make both the left and the right hand side equal the same to each other. And then finally, part D. I think this is probably a step backwards as compared to the previous problem. So we've got here 42, and then I'm going to rewrite this as 6 times x plus 15, and then minus 6. 42 equals 6 times x. And when I take the 15 and subtract 6, I get a plus 9. So that's 6x and then plus the number 9. And the next thing I have here is I'm going to take away a 9 from each side, so I get that 33 is what 6 times x is. And if I divide both sides by 6, we get 33/6 is x. And there is a common factor of 1 there. If you wrote that answer down, I don't think I would care. I would probably give you full credit. But it's in general, and I might change my mind about that, but come and argue with me later. But in general, you should not leave any common factors, right? You want these answers to be in the simplest form possible. So this is clearly 11 times 3 in the numerator and a 2 times 3 in the denominator. So the preferred answer would be 11 halves. So I'll write that down for part D. X is 11 halves.